Hello there. Today I would like to share with you another tool that I've developed a long time ago. It's a tool that I had developed to help understand the concepts of distance relay protection. And so this is a way to grasp the concepts, but as well as a aiding tool for calculation of distance relay protection. So here, what you have here on the top, on this side, you've got an impedance that is supposed to represent the load impedance, uh, calculated from the voltages that you can see here on the left-hand side and the current on the right-hand side. Um, so you've got the voltages on the A, B, and C phase, which is 100 volts in amplitude, 5 amps for the currents. What you can see here is that when you change the current by dragging the tip of the vector here, typically the current would be lagging for a fault on an A phase, for example. So if I drag it here, you can see that the impedance calculated here would change accordingly. You can hover on the vector representing the calculated impedance, which is in this case ZAB here and there ZA. Um, you have as well the representation of the zone impedance, which are color coded when the impedance, any of the impedance, get into their zone. So here you can see that ZA is in the zone 2 area and the ZAB is in the Z3 area. One way to get to the zone 1 here, it would be to increase the amplitude of the current IA. So now you can see that we get the ZA in the zone 1. Okay, so you can do the same with the voltage. You can play around and see how it affects the impedance seen by the relay. You will see on the bottom here that the zero, positive and negative phase sequence voltages and currents are calculated as well as represented here on the bottom. So that's just a visual, but as well a real tool to be able to get the values straight from this representation. You'll see on the top left-hand corner, you've got the actual voltages and currents that are represented here. You can change any of them and see how it affects the voltages, but as well the impedances. For example, if I change the amplitude of the zero sequence voltage, let's drop it from 34 to 10 volts. So you can see that it has changed automatically. You can see you can do the same thing with the angle. So all that is just a way to really look at how all this is interacting. Here you've got as well another tab here where you can see the phase-to-phase values for the voltage and current. Again, you can change any of these values. Let's drop it from 103.3 to 10 volts on the B phase. Okay, so you can see that it's pretty flexible here. You've got as well another tab that I've got here for the Z impedance that are calculated. You can see that the values are there for ZA, ZB, ZC, and ZAB, ZBC, and ZCA. You can see as well the neutral current and the K factor, which is a factor that is calculated from the zero sequence and positive sequence impedance. The characteristic of the relay here, you see that we have an 8 ohm zone 1 reach. Well, excuse me. We've got a ZL, which represents a line protected of 8 ohms. So you can see that here the 8 ohms is here represented by this blue line. Okay, so here we've got, so that this is the impedance line that is protected here. We've got an 8 ohm with an 80 degrees. You can see that it's aligned with a 0.4 ohms per units of length. So since I've got 20 units of length, 20 times 0.4 makes 8 ohms here. So if I drop it to 10 to 10 units of length, so you'll see that it drops to 4 ohms, and the ohm characteristics reduce accordingly. You can change the angle as well. So typically, if you've got a cable, you'd probably drop the angle to something smaller, so you can see that it reflects automatically here on the impedance plane. So, and you can as well change. Let's put it back to 80 degrees. Let's as well change the zone 1 to 90. Okay, so you can play around with these, and it's pretty flexible. Here, the K factor as well, you can play around with the K factor, so which is a pretty cool feature, and see how it affects the impedances seen by the distance relay. Okay, so on the right hand side here, you can reset the voltages and reset the current so that we can start with a clean slate. So let's reset them both, so we're back at where we were. Let's concentrate here on these buttons. You can see that you can simulate an A to ground fault here, and see how it reflects on the impedance plane. You can do the same with the B to ground, C to ground, A to B fault, B to C, C to A. The same thing with an A to B, face to ground fault on AB phase, BC to ground, CA to ground, and then the three-phase fault, which is pretty straightforward. So here you can as well lock the current, so that if you want to simulate a three-phase behavior, you can drag the tip of the current without having to change each of them, and it would be a little of a struggle. Here you can do the same with the voltages, and so you can see how it affects everything, as well as what you see on the bottom here with the symmetrical components. So you've got you have a zooming and a panning capability as well for convenience. So this is pretty much it. I think I've covered all of what you can achieve with this tool. So again, this is a tool to aid understand the concept of distance protection, as well as being an aiding tool to calculate all these faults that you might have in your studies, relay studies. So I hope it helps. Let me know in the comments whether you've got any ideas or suggestion on this tool. So I'll talk to you in another video on with other tools that I've developed. Thank you, and talk to you later.